Hey there everybody, in this lesson we're going to look at how to graph the secant and cosecant functions, and we're going to talk about some transformations of those functions, including vertical stretch and shrink, and period change, and also phase shift. So here we go. Let's start out by taking a look at the basic cosecant function. Like tangent and cotangent that we saw in the previous section, cosecant has vertical asymptotes. Now remember that vertical asymptotes occur wherever a function has undefined values. And we're going to use the sine of x as a guide for cosecant x because sine is the reciprocal of cosecant. Also, because cosecant is a reciprocal of sine, cosecant is going to have vertical asymptotes wherever sine of x had x-intercepts. Also, since the reciprocal of 1 is 1, the graphs will touch at the highest and lowest points. So wherever sine of x had a value of 1, cosecant will also have a value of 1. And on the negative side it works too. Wherever sine had a value of negative 1, cosecant will also have a value of negative 1. On this slide we're going to graph a couple of periods of the cosecant function. And the way we're going to do this is, first, we're going to graph 2 periods of the sine function, but we're going to do it with dotted lines so that the sine graph doesn't stand out so much. And then we're going to draw asymptotes in, also in dotted form, everywhere the sine function had an x-intercept. And then the graph of cosecant x will go between the asymptotes, and we'll see that in a minute when we get a little bit closer to it. I'll show you how that goes. Okay, first remember how we drew the sine function. We would put a starting mark on the axis and then 4 more evenly spaced marks. This would be the end of the first period, so this would be 2 pi. And then 4 more evenly spaced marks, and then this will put us at 4 pi. Okay, now the y-axis, the amplitude of sine x is 1, so the y-axis needs to be labeled from -1 to +1. And then the period of the sine function is middle, high, middle, low, middle. And so let's put very lightly dots here, middle, high, middle, low, middle. Okay, it's hard to see the ones that are on the x-axis, but they are there. And now we'll lightly draw in the sine function. So do it in dotted form so it doesn't stand out. And now remember that the cosecant is actually the reciprocal of the sine function. So everywhere the sine function had an x-intercept, cosecant will need to have an asymptote. And even the y-axis itself is an asymptote. I don't know how well you can see that, but the y-axis itself becomes an asymptote. Now, to actually draw the cosecant graph itself, remember that the reciprocal of 1 is 1, and the reciprocal of a small positive number is going to be a large positive number. The smaller this number gets, the larger the reciprocal gets. And the same thing here. The reciprocal of a small positive number is going to be a large positive number. And so for this little section of the sine function, the reciprocal cosecant function will look like this. Okay, now that is one branch of cosecant, but it's not a whole period, because you're going to see that when we get to the second half of the sine function, that branch is going to have to open downward. You see the reciprocal of a negative y value is going to be also a negative y value, but because this one's less than more than -1, its reciprocal is going to have to be less than -1. And then we'll see the same thing happen here and here. Now notice that unlike the tangent function, where every branch of the tangent function represented one period, here it takes 2 branches to represent one period, because not all the branches are identical. We have positive ones or upward opening ones, and we have negative downward opening ones. So it takes a pair of branches to make one period. All right, now let's analyze. We'll look at all these values. Now the period, remember, is how many radians it takes to get from the beginning of one cycle to the beginning of the next cycle. And since cosecant is based on the sine function, they have to have the same period. So the period of the sine function is 2 pi radians, and therefore the period of the cosecant function is also 2 pi radians. Okay, now where are we seeing asymptotes? The asymptotes appear to be occurring at, well, I see 2 pi here, and therefore this must be 1 pi, 2 pi, 3 pi, 4 pi. So the asymptotes are occurring at all the whole pi's. So we'll write n pi, where n is any integer. And the x-intercepts of the cosecant graph. Now remember, we're talking about x-intercepts of the cosecant graph. So maybe we ought to pause here and kind of erase the sine function. Okay, here we go. And now, without the sine function in the way, you can see that the cosecant graph does not have any x-intercepts. So for x-intercepts, we can put none. And the domain, remember, is everywhere that the graph appears except we have to leave out where the asymptotes are because the graph doesn't exist there. So remember, the asymptotes are occurring at every whole pi. So we'll say the domain is every x such that x is not equal to n pi, where n is any integer, but we won't write that again. Now the range is coming in two pieces. We have these bottom branches and these top branches. So in interval notation, we can say that the y values go from -infinity to -1, and then from 1 to infinity. And cosecant has no amplitude because this graph does not oscillate up and down the way sine and cosine did. Now let's get you to practice drawing a couple of periods of cosecant on your own. So I believe on your notes that you've printed out there are two different coordinate systems for you to practice with, and I hope you'll pause the video and actually practice drawing this. So first of all, go ahead and lay out your starting mark plus your 4 evenly spaced marks for each period you want to draw, and then draw in your sine pattern, middle, high, middle, low, middle for each period, and then sketch in your sine function, and then go ahead and draw in asymptotes at every x-intercept of the sine function. And then for the positive parts of the sine function, the cosecant will open up. And remember, you're just going to let it touch right there. You're going to let the cosecant function touch the top of the sine function. And here at the negative part of the wave, you're going to let it open down. And then repeat for each period. And that's it. Now while we're at it, let's go ahead and pick up the secant function. Secant also has some vertical asymptotes. We use cosine as a guide for the secant graph because of that reciprocal relationship. And since secant is the reciprocal of cosine, secant will have vertical asymptotes wherever cosine had x-intercepts. It is exactly the same idea that we saw with sine and cosecant. Okay, so we're going to draw the graph using the same method as before. We're going to draw two periods of the cosine function, and then we're going to draw asymptotes at every x-intercept of the cosine function, and then the graph of secant x will go between the asymptotes. So here we go. You can just quickly sketch in your horizontal axis, two periods, 1, 2, 3, 4, you're at 2 pi, then 1, 2, 3, 4, you're at 4 pi. Label your y-axis from -1 to +1. And then remember the cosine function pattern goes high, middle, low, middle, high. And draw in your cosine function. And now remember, the reciprocal graph is going to have asymptotes wherever the guide graph had x-intercepts. So that's going to happen here. In this case, the y-axis itself is not an asymptote, and we have asymptotes at every x-intercept of the cosine function. Okay, now here, because we have a little half of a crest of the cosine wave, we're going to get a little half of a u, like that. And then here is a negative portion of the wave, so we're going to get that u opening downward. And this one's positive, so it's going to open upward and then downward. And then here we're going to get another little half of a u, like that. Okay? Now the period is the same as the period of the cosine function. So it takes 2 pi radians to cover one period of cosine, so it's going to be 2 pi radians to cover one period of secant. And yeah, let's go ahead and erase our cosine function. 2 pi radians for the period. And then the asymptotes are occurring, it's hard to see here because they're not labeled. So let's label them. Let's see, this is 2 pi, so this is bound to be 1 pi. And then these are bound to be like 1/2 and 3/2 pi. You can tell that because this one's halfway between 0 and pi, so it's got to be 1/2 pi. This one's halfway between 1 pi and 2 pi, so it's got to be 3/2 or 1.5 pi. And so you'll remember probably from the cosine graph that it had x-intercepts at the odd pi over 2's. So remember, we write odd as 2n plus 1. That way n can be any integer, and we should have written that there. Okay, now the x-intercepts again are none because the secant graph cannot come anywhere near the x-axis. And the domain is all the x values except where we have asymptotes. So that's going to be every x value that's not equal to an odd pi over 2. Okay, range. It's the same as the cosecant range. We have this lower branch that goes from -infinity to -1, and we have these upper branches that go from 1 to positive infinity. And just like cosecant and tangent and cotangent, secant has no amplitude. Okay, let's practice drawing a couple of periods of the secant function. So first we're going to draw our cosine function as a guide, and so I've laid out my horizontal axis and my vertical axis, and I know the pattern for cosine is high, middle, low, middle, high. There's my cosine function. The asymptotes are going to appear wherever the guide graph has x-intercepts, and then just use reciprocal values. So these are positive. The reciprocal is going to be positive, but it's going to go the other way. And remember, this reciprocal of 1 is 1. The reciprocal of -1 is -1. So these graphs should touch, these secant and cosecant graphs should touch the sine or the cosine guide graph at the high and low points. So here we're going to have a graph that touches, but then points down. And here we're going to have a graph that touches the top but then opens up. Same thing here, but it's going to open down. And same thing here, but this is a half of a crest, and so it's going to be just half of a u. Okay, now we get to some transformations, and you might think that this is fixing to get really complicated, but it actually does not get so bad if you know how to graph transformations of sine and cosine. But what we're going to do is to graph a cosecant bx or a secant bx, all you have to do is use a sine bx as a guide, or a cosine bx if you're doing secant. So figure out the guide graph, go ahead and sketch in the guide graph, then wherever it has x-intercepts, draw your asymptotes in, and then go ahead and draw in the branches. And so let's give it a try. Okay, so first of all, this is secant, so we know that our guide graph is going to be 2 cosine of 1/2 x. You see, the only thing that changes is the function changes. The 2 is still there and the 1/2 is still there. Okay, now when we were drawing things like this, we would start by looking at the A. So A is 2, that means amplitude is 2. B is 1/2, that means period, remember, is 2 pi over B. So that's going to be 2 pi over 1/2, which is 4 pi. Because remember, to divide by 1/2 is to multiply by 2. Alright, there is no phase shift here because we don't have a bx minus d or anything like that. So I'm going to go ahead and lay out my vertical axis with my amplitude, and then 4 evenly spaced marks, and the fourth one is 4 pi and 4 more, and the last one is 8 pi. And then we'll use the pattern of the pattern of cosine, which is high, middle, low, middle, high. Sketch in your guide graph, and then sketch in your asymptotes. Everywhere you see x-intercepts for the guide, put in asymptotes. And once you get the guide drawn, then it's easy to sketch in the branches. Okay, so let's try another one. Okay, now we're going to graph 3/2 cosecant of x minus pi over 2. And so let's start out by getting the guide graph that we need. That would be 3/2 sine of x minus pi over 2. All you have to do is change the function to the reciprocal function, and that will be the guide graph that you need. So here we see A is 3/2. That means amplitude is 3/2, which is like 1.5. And B is 1. You see here, remember, B is the coefficient of the x. So B is 1, that means period is 2 pi. Remember, the formula was 2 pi over B, but when your B is 1, period is just 2 pi. Now the phase shift you can see here is pi over 2 to the right. And so let's go ahead and calculate the end of each cycle. We're going to draw 2 cycles. So take your starting place and add a period to that. We'll need common denominators here. That's going to be pi over 2 plus 4 pi over 2. And that's going to add up to 5 pi over 2. And then we'll do the second cycle. We'll take our 5 pi over 2 starting place and add a period, and that's going to put us at 9 pi over 2. Okay, so right here, pi over 2. And then 4 evenly spaced marks, and that puts us at 5 pi over 2, and 4 more evenly spaced marks, and that puts us at 9 pi over 2. And I went ahead and drew my y-axis up to 2, but I know that the amplitude is really only 1.5, so right here is the high and the low that I'm shooting for. Okay, now the pattern for sine is middle, high, middle, low, middle. So starting here at the phase shift, middle, high, middle, low, middle. And then draw in your asymptotes. Everywhere your graph has an x-intercept, draw in an asymptote for your cosecant graph. And then here we have these positive crests. Then that'll give us the upward opening U, and the negative parts of the graph will give us the downward opening U. And there it is. Okay, now here is another one. Secant of 1/2 x plus pi over 3. So our guide function is going to be cosine of 1/2 x plus pi over 3. And let's analyze. A is 1. That means amplitude is 1. B is 1/2. That means period is 2 pi over 1/2. And to divide by 1/2 is to multiply by its reciprocal. So period will be 4 pi. And now let's figure phase shift. Now you can't just say that phase shift is pi over 3, because remember, B also affects phase shift. So to get phase shift, we'll have to take what's in the parentheses and set it equal to 0. We'll move the pi over 3 to the right side, and we'll multiply both sides by 2. And so the phase shift will be negative 2 pi over 3, or in other words, 2 pi over 3 to the left. Now, because our phase shift is to the left, we'll need to calculate the first quarter mark so that we'll know how far apart to space our 4 evenly spaced marks. So, negative 2 pi over 3 plus a fourth of the period is going to mean negative 2 pi over 3 plus pi. And to get common denominators, we'll say negative 2 pi over 3 plus 3 pi over 3, which puts our first quarter mark at 1 pi over 3. So that's good news, actually. It means that our first quarter mark is to the right of the y-axis, and we don't have to calculate any other quarter marks. Okay, let's go ahead and calculate the end of the first cycle. That would be the starting place, which is negative 2 pi over 3, plus a whole period, which is 4 pi. And getting a common denominator, we will get this to add up to 10 pi over 3. And we'll do the second one in a minute. I'm kind of out of room down here. Okay, so here is my starting place and my 4 evenly spaced marks. So notice that this one is at positive 1 pi over 3. And the end of the first cycle is at 10 pi over 3. Okay, now what I've done is I took my 10 pi over 3 and I added another 12 pi over 3 to get this 22 pi over 3. I just didn't have room to write it down. And then for our vertical axis, we said amplitude is 1. So the pattern is high, middle, low, middle, high. And starting back here at the phase shift, high, middle, low, middle, high. And you can see we'll fill that in. That looks like a cosine graph. And now let's go ahead and draw in asymptotes everywhere our graph has x-intercepts. So that little half of a crest is going to give us a half of a U. And there is the secant of 1/2 x plus pi over 3. Okay, we have one last graph to look at together. This one is negative 1/2 cosecant of x plus pi over 2. So the first thing that we know we need to do is get our guide graph. It's going to be negative 1/2 sine of x plus pi over 2. And we see that a is negative 1/2, which means that amplitude is 1/2. And the negative means that there's a reflection across the x-axis. And b is 1, you see here, so that means period is 2 pi. And the phase shift is going to be pi over 2 to the left. And we just can say that since b is 1, we really don't have to solve anything. Okay, now, because our phase shift is to the left, we will have to calculate the position of the first quarter mark. So we take the starting place and add a fourth of the period. So that's going to give us, in this case, negative pi over 2 plus 1 pi over 2. When you simplify that fraction, gives us a nice common denominator there, and those two add up to 0. And so we see that our first quarter mark is going to go on the axis itself. That's good. And then we can space out the rest of the marks after that. Let's calculate the position of the end of the first cycle. That's going to be the starting place plus a whole period. So in this case, negative pi over 2 plus 4 pi over 2. And that's going to add up to 3 pi over 2. So here is the phase shift. So pi over 2 to the left. And then I know my first quarter mark goes on the axis, and then the rest of the evenly spaced marks. And there my fourth evenly spaced mark is at 3 pi over 2. And we could go ahead and add 4 more marks, and 3 pi over 2 plus another 4 pi over 2 gives us 7 pi over 2. Now our y-axis, we know amplitude is 1/2, so we need the 1 mark, and 1/2 would go halfway between the x-axis and the 1. So there's 1/2, and there's negative 1/2. Now for the pattern, remember that this is sine, so it's middle, high, middle, low, middle, but it's got a reflection across the x-axis, so it's actually going to end up being middle, low, middle, high, middle. So here you see, starting at the phase shift, middle, low, middle, high, middle. And I see that I've got my dots in the wrong place because they should be at 1/2. So let me fix that. Okay, so now the dots are fixed to reflect the correct amplitude. And let's go ahead and get our second pattern of dots to make the second cycle. And we'll draw in our reflected sine function. So middle, low, middle, high, middle. And then let's go ahead and draw in our asymptotes at every x-intercept. And then we see we have negative values here, so the u will open down. Positive values here, so the u will open up. And so on. And there's our function, our graph. And so now on the next graph, on the next slide, we're going to look at some graphs and see if we can come up with the equation. So let's try that. Now the key to coming up with the equation for these graphs is going to be getting the guide graph drawn in correctly. Remember that the reciprocal of 1 is 1, and the reciprocal of an asymptote is going to be an x-intercept. So let's go ahead and see if we can draw in the graph that fits between these two u patterns, and it looks like a sine function. So let's go ahead and analyze the a and the b. I see amplitude is 1, and that means a is 1. I see that the pattern is a sine pattern. I see that there's a half of a period between 0 and 2 pi, and that means that b is 1/2. And so now that's going to fit into our pattern for our function. It's either a cosecant bx or a sine bx. And so we know that since this is a sine guide graph, it's going to be a cosecant function that they drew for us. So y equals 1 cosecant of 1/2 x. So a is 1 and b is 1/2. For this next function, we've got y value of 1 here. And so when we draw in our guide graph, we're going to get a 1 here, and here are asymptotes, so we're going to get x-intercepts there. And the guide graph we have to draw in between these branches looks like this. Now, if you start back here at negative pi over 4, you could say that this is a phase-shifted cosine graph that's been reflected. So low, middle, high, middle, low. You certainly could take it that way, but you also could just start at the y-axis and say that the pattern is high, middle, low, starting at the y-axis so that we don't have to consider phase shift. We start high, middle, low, and so it's not an upside down cosine after all, it's a right side up cosine. So the graph is going to be a secant graph. So let's say amplitude is 1 and the pattern is cosine, and the period goes from, well, this is the middle, I guess, of one period, and this is the middle of the next period. So you get a whole pattern in here. And so the period goes from negative pi over 4 to positive pi over 4. In other words, pi over 2 radians from one to the other. And so what I've done here to try to find period is I've plugged into my period formula. So period equals 2 pi over b. Now I need to isolate the b. So what I'm going to do is multiply both sides by b, like that. And then I'm going to multiply both sides by this reciprocal to isolate the b. And it's going to end up looking like b equals 2 pi times 2 over pi. And the pi's will cancel out, and b equals 4. And now you might be saying, well, why did we have to use the formula here? And back here on this last example, we did not have to use the formula. We just looked at it and said that b is 1/2. Well, that's because on this last one that we did, we could see the 2 pi on the graph. And so we were able to just look at it and know what b was supposed to be. But here, our graph is not showing us 2 pi. So we kind of have to use the formula to force the period to show up, or to force the b to show up. And so b is 4. And so now, since this is a cosine graph, the graph that they drew for us was a secant graph, so y equals secant of 4x. And finally, this last one, we have a y value of 1 here. So our guide graph is going to have a y value of 1, and x-intercepts here and here. So there's our guide graph, and that looks like, again, a cosine pattern, because you could think of it as a phase-shifted upside down cosine, or you could think of it as a phase-shifted sine. But the easiest thing to do is just to start here and say, well, if I start here, this is a cosine graph, and so what they've drawn for us here is a secant graph. So thinking of it that way, amplitude is 1, and the pattern is cosine, and we'll have to figure out b. So let's get period. Period goes from negative pi over 2 to positive pi over 2. So period is 1 pi. And we do not see 2 pi on our graph. So let's go ahead and plug into our formula. Period equals 2 pi over b. Multiply both sides by b. And now multiply, or divide rather, both sides by pi. And we can see that b is 2. And so y equals a secant bx, in this case 1 secant 2x.